Okay, so again, pre-calculus 30, we're looking at chapter 7, 8 review questions. Here's, I was asked about number 16b and 18a, so let's take a look at those. 16b says, write each expression as a single logarithm in simplest form and state any restrictions. Okay, so let's take a look at b here. And order of operations would probably say that we should do inside the brackets first to simplify this. So for b right here, let's leave the 1/3 out there. And let's write this as, because they both have the same base, so this subtraction of logarithms means that we can write this as log base a of x divided by root x, okay, plus this one over here, 3x squared base a. Now, this simplified, right, x over root x, well, that's equal to x to the 1 divided by x to the 1/2, which is equal to x to the 1 minus 1/2, or x to the 1/2. So this x divided by root x is root x. So now we have 1/3 log of root x, or let's write that actually as x to the 1/2 base a, okay? And then what we can do here is we can take this coefficient, again, rules of logarithm, the power rule here, I can write this as log of x to the 1/2 to the power of 1/3. And what does that do for us? Well, we can multiply our exponents if you have a power raised to a power, right? Oops, I forgot my a. So that's x to the 1/6. Hey, we're getting close. We're getting really close here now. And now, because we have a sum of logs, that rule says that we can write this as a single logarithm where this is multiplied with this right here. So I have, I'll write this first, 3x squared times x to the 1/6. And when you multiply terms and they have variables with the same base, you can simply add their exponents. So let's see, this becomes log base a of 3, and this is going to be, so 2 plus 1 over 6, what is that going to be? That's going to be, 2 is actually 12 over 6, plus 1 over 6 is 13 over 6, if I'm doing that correctly. X to the 13 over 6, 3x 13 over 6. Let's just check that. Okay, so fine, that's great. That's a great answer. We got to state any restrictions now. So if you look at the original question, you can spot a few things. Remember, you can't do the log of a negative value. So actually this right here, this will never be negative. X is not restricted by this one because we're squaring x. So x could be -5 because when you square it, it becomes positive 25. So x could be anything here. This is a problem, right? We can't take the square root of a negative number, nor can we take the log of a negative number. So it looks like x has to be greater than 0. So with x greater than 0. So this would be your final answer there for 16b. Okay? So that's 16. That's 16b. I'm going to move to 18a here and do one more final question before we move on. Let's see if I can get this down here for you. Maybe. What happened there? Oh, whatever. Okay, let's see if we can move that answer down there. There we go. Just so we don't get rid of everything. All right, and I'll get rid of this nonsense. That arrow doesn't mean anything anymore. All right, so let's do 18a as well. It says determine the value of x. Round your answers to 2 decimal places. So answers to solve for x. Okay. All right. Now we have exponential equations here. So I'm going to take the log of both sides. Log of 4 to the power of 2x plus 1, and I'm going to take the log of 9 times 4 to the 1 minus x. Okay. This 9 out here is not subject to this exponent, okay? This is just a regular 9 to the 1. But because they're factors, 9 times this 4 power, I can separate the logs here. That's what I'm going to do. Log of 9 plus log of 4 to the 1 minus x. You see that? I'm using the laws of logarithms that I used in the previous question, just in reverse. Now I'm going to bring this exponent down, and I'm going to have something that looks like this so far. this exponent can come down as well, which is going to be 1 minus x times log 4. So I'll just, to save space, I'll do that here. Okay. All right, so now you see, here's the x. Here's my x over here, and here's an x over here. I got to get those together. I need x in one spot. I can do it, but I'm going to have to distribute here. I'm going to have to distribute this here, and I'm going to distribute this here, so I can get my x terms on the same side. So I'll just do that in the background here. All right, so I've done a couple steps of work here. I noticed that I have a log 4 on both sides, and that's what these go away. And I'm going to factor an x out here. So I have 2 log 4 plus log 4 equals log of 9 over here. I can simplify this, and then I can divide both sides by this, and then I will have my value for x. So I have x. Now I'm going to do a couple steps at once. Watch carefully. I'm going to do this log 9. I'm going to divide by this. Now what is this? Well, that 2 goes up here, so that's actually a 16. And because I'm adding logarithms, I can multiply 16 times 4, right? So what's 16 times 4? 4 times 10 is 40. 4 times 6 is 24. So that's 64. So that's actually log of 64 here. Okay, is that right? Yeah, 4 cubed, really, is what that is. 64. So now it says we can solve to 2 decimal places, so I think I'm good here so far. Have no idea what the answer is, but let's keep going here. So log, sorry, let's clear this up. All right, so where am I? Log 9 divided by, and now I could do just one single log, right? But but I'm going to do it just as it's written. Log 64. Okay, log 9 minus 64 equals, okay, 0.5283. So let's see, 0.5283. So let's just review our work here and just see if that looks good. Okay, I think we've done everything correctly. 2 decimal places, the answer. So x actually would equal 0.53. That should be our solution. Now, we want to double check to make sure that that's not going to be an extraneous value for an answer, right? Make sure that it's allowed. So are there any restrictions on the variable that would eliminate this? Well, 2 times 0.5 plus 1. That's going to be positive, no problem. Oh, we don't have any logs. We don't have any square roots. So guess what? There's no restrictions on x, I guess, right? X can, this powers can be positive or negative or 0, doesn't matter. So there's your answer. Okay, so that's the answer to those 2 questions from the cumulative review that you asked about there, and I hope that helps.